Well, thanks everybody for coming out. Thanks to Brandon for organizing MongoDB meetup. My name is Sandeep, Parikh. I'm a solutions architect. I was going to say at Tengen, but at MongoDB. I don't work for Tengen anymore, unfortunately. But that was a little joke. Nobody laughed, though. That's fine. I don't know if you guys know, but the company used to be called Tengen. We recently changed the name to MongoDB. But we've had this meetup group going for a while. So we've been trying to do like more and more advanced topics. But Brandon had a good idea of like, let's do kind of an intro. It's the new year. And then we'll use this as kind of a jumping off point for more advanced things. So if you see a topic you want to hear more about later on, or if you have an idea for a talk, or if you want to see like a deeper case study around like a specific data model or schema design, by all means, please share those suggestions with us. That way we get the right speakers and the right content in here, so it's useful for everybody. Because we don't want to just keep doing intro stuff or like the same topics over and over again. We'll make sure it's as useful as possible. Object Rocket was kind enough to sponsor and get some food, so if you haven't grabbed some food or beer, please do so. And Capital Factory is always gracious with their space, so say thanks to those guys on the way out too, and don't make a mess. Otherwise, they won't invite us back. With that, we're gonna get started. So, what I want to talk about today, as an overview, was this notion of like building your first app on MongoDB. It's sort of the quickest way to get started, right? We just want to get you like 0 to writing code against MongoDB and show you how easy it is and what you can really do with that in the long run. And then we'll kind of leave the door open for sort of advanced topics. And if at any point you have questions, feel free to like jump in, raise your hand, ask a question, blurt it out. And I'll try to answer it without around. So what is MongoDB? MongoDB is, a document database at its core. A document isn't like a Word doc, right? We're talking more about like JSON objects. So you could sometimes call it like an object database, but it's really just a document database. Documents are JSON objects, but it's open source. It was really built to be high performance and horizontally scalable, and also really be full featured. The two like core tenets of MongoDB that we try to adhere to as much as possible are agile and scalable. And so agile is everything from writing code against MongoDB, iterating your dev model, your data model, your schema design over time, all the way to like being agile with your deployment, which kind of feeds into scalability. We want you to be horizontally scalable. We want you to have like some vertical scale if that's possible. But we want the entire thing to be iterative from top to bottom, whether it's your code, your data, or your deployment. So it's really what the core of the system was based around. And a lot of what we're doing on a regular basis to improve it is around those two key areas. Again, it's not a PDF or a doc file store in sort of the classic document sense. It really is around JSON objects or JSON documents, as we call them. If you think about how JSON maps to back to your like language of choice, if you think about Python, you represent JSON in Python as basically a Python dictionary. That's actually how you treat data with MongoDB. It's just like working with a Ruby hash or just a PHP array or a hash map in Java. We do a lot of heavy lifting behind the scenes in our drivers to make sure that it's really easy to basically work with this data in a data structure you're familiar with, like a dictionary in Python, and then just dump that straight to MongoDB. When you read and write data, it comes out as Python dictionaries. So we do a lot of that work to like move things around the background. So what you're working with is what you're used to working with when you write code. MongoDB is open source. So there's basically two flavors of MongoDB kind of out there. There's sort of the standard / community edition. That's obviously open source. It's AGPL licensed. We do take pull requests, though I think you have to sign a contributor agreement based on the way the AGPL reads, which is kind of onerous, but that's okay. It was started originally by Tengen several years ago. So the initial idea was two of the founders of DoubleClick built this crazy ad network. They sold it to Google, decided they want to start another company. They started Tengen. It was supposed to be a platform as a service, actually. They wanted to build a platform as a service that could effectively run an ad network. Along the way, they started building a database. Turned out the database was more interesting than the rest of the code. So basically shoved everything else off to the side and focused on MongoDB itself. Over time, it was always Tengen makes MongoDB, and just over the course of it, it just made sense for us to rename the company to MongoDB. That's what we're working on. We have a lot of stuff kind of associated with MongoDB, but that's really the core product. There's also an enterprise version that we do like commercial licensing around, and that we sell, sort of to enterprise. MongoDB Enterprise and Community are more or less the same thing. There's a couple of key differences though. SSL is available in the open source version, but you have to build it yourself. In MongoDB Enterprise, SSL is already compiled in. Part of that's export reasons. There's also support for more advanced authentication in MongoDB Enterprise. So we have support for Kerberos right now, so you can plug it into Active Directory. But we're also adding support for LDAP later this month, actually, or sort of early in 2014. And then there's other kind of, you'll start to see like some of that difference extend out a little bit further between enterprise and community. But all of the core database features, querying, indexing, JSON support, full text search, geospatial support, all that stuff is always going to be in community. The stuff that kind of skews enterprise is stuff that fits in, again, to enterprise. So think of like SNMP with MIB support. Your average company doesn't need that, but certain enterprises do, so it's an enterprise feature. Kerberos is kind of the same thing. So that's the kind of dividing line between those two. And then enterprise also ships with a few other things like a commercial license if you don't like open source. Some companies, some really big companies don't, especially like banks and those kinds of people. And then there's also support for some of like the cloud hosted tools I'll talk about as on-premise versions with MongoDB Enterprise. It is intended to be high performance, even though sometimes it can feel like it's not, depending on what you're doing, if you're doing it wrong. But it's written in C++. We do everything through memory mapped files. So we do a lot of punting to the OS in terms of helping manage storage and managing what gets paged in and paged out. We can talk about that more in depth if anybody has any questions. But it runs a lot of places. So we do community builds for Windows, Mac, and Linux, and we have specific versions for Yum-based and app-based distros. Then we have MongoDB Enterprise, same thing. We don't support production deployments on the Mac, but we do support them on Windows and Linux. So if you've got that in your setup, you should be able to find the target to deploy onto. Data is serialized as BSON. So if you remember, I kept on talking about JSON. So when you work with data back and forth, it feels like JSON, it looks like JSON. What it's actually doing in the background is we're using a data type we created called BSON. Think of BSON as like a superset of JSON, right? We took the JSON spec, added a few formalized numerical types, added a formal date time type, and I think changed some of the way we sort of encode it in binary to store it, but that's really it. So you really won't deal with BSON directly at all. You're effectively dealing with JSON all the time. So much so that if you write a little client or app that goes and pulls JSON data from an API, you're literally just going to stuff that right into MongoDB. There's nothing you have to change to make that happen. Full support for primary and secondary indexes. Secondary indexes are like a top level feature. It's not kind of buried off to the side. It really is intended to be whatever you write to MongoDB, you should be able to read back out, however you want to read that back out. Whether it's some element nested deep in JSON somewhere at the bottom, or something at the top level, or a string or a compound object, it doesn't matter. If you can model in JSON, you can basically build an index around it, and that becomes a secondary index. The idea with the document model and why they went this route, why the two founders went this route initially was really to get less work. It's like a silly analogy that our CEO uses all the time. If you think of like parking a car, if you park a car in a relational database, you end up taking the car apart and putting the doors over here and the windows over there and steering wheel, all those things. Your code doesn't actually work with a door or a window or a steering wheel. It works with a car. So the purpose of the document model was really to let you model those objects the way you work with them. So if you work with cars, that's what you write to the database as a car object. When you pull it back out, it's a completely built car. That has a lot of good implications and some downsides, right? Some downsides are MongoDB doesn't support things like joins. We don't support things like cross-table transactions. So that is definitely a huge distinction from the way relational databases work. But because we made those design decisions early on, it allows us to add a lot of scalability because we're dealing with just kind of objects on their own. So scaling a collection of cars is actually pretty straightforward. It can be done in a reasonably distributed way. Scaling, random bits and pieces like steering wheels and tires and windows, that's a little bit harder over time. Any questions so far? Cool. All right. MongoDB is intended to be horizontally scalable. So our notion is that you deploy it if you need more scale. You effectively have to go through the process of taking your data set and saying, well, how do I want to split this data up? How do I want to partition it? And then you effectively add capacity. And we actually do a lot of the legwork to smooth that data set across multiple shards. And we try to help you, manage things like request distribution across a cluster so that it's got good scalability, good performance. There are a lot of nuances there to make it happen in a really smooth manner, but all that stuff is kind of built in out of the box. It's intended to do that as quickly as possible. if you look at the broader kind of database landscape, and this is a cheesy graphic that I think somebody in marketing put together, but if you kind of graph MongoDB against things like key value stores and memcache or like relational database system across this sort of fake scalability versus functionality curve, memcached key value stores themselves, they're super high performance. They're really, really fast. The problem is there are limitations to the way you can model data. There are limitations in the way you can use that data in the long run. On the other hand, you have relational systems where you can do anything. You can model anything you want to, but there are some scalability considerations you have to take into account over time when you're doing things like cross-table transactions across a distributed cluster. Right? That stuff's really hard. We kind of like to think of ourselves as fitting pretty high in the scalability curve and pretty far along in the functionality curve. Not as deep on functionality in terms of relational, but the trade-offs there are that you get a lot of scalability and you get it pretty quickly and out of the box. So that's the big distinction there. If I were to kind of put like Couchbase, Cassandra, and those guys in, they would be kind of further back along between this section of memcached and MongoDB. That's not a knock, right? I think they're like every database is kind of intended to do something different. We were intended to do a lot of what relational could, but back it off a little bit so we could get to scale. If you look at things like Cassandra, Couchbase, those guys are really built for scale, but they make some trade-offs in the data model. Nobody would ever tell you, or if they do, don't listen to them, that one database solves all your problems, right? You're not going in there and saying, well, I have MySQL deployed. I'm going to rip it out and replace everything with MongoDB. That's not a solution. Nor is it a solution to replace Cassandra with Cassandra or with Riak or Couchbase. The better solution is like right tool, right problem, find the right fit, model the problem out, test your assumptions, and iterate. All these things are meant to be iterative. Take advantage of that. All these databases can be downloaded. You can run them on your laptop. You can try things out. You can break them. Do that. Take advantage of it, because that's how you really understand what's the right tool for what you're trying to build. So MongoDB is pretty full feature, though, if you kind of go back to that feature curve. Total support for ad hoc queries, right? That means when you write data, you can read it in a number of ways. You can read things, like I said, that are deep nested objects. You can read with things like range queries. A lot of the same functionality you would expect out of like a relational database is represented in MongoDB pretty well. We have a built-in real-time aggregation mechanism. So think of all the things you would typically do with like SQL group by. All that's reflected in MongoDB, and actually more. We have a mechanism built in called the aggregation framework, and it effectively lets you design like kind of a pipeline of operations. So think of like the Unix pipe operator. You list a bunch of files and you pipe that to grep. You grep for something. You may cut out a couple columns, and you kind of transform that output, which becomes the input to the next phase, through and through until you get that final result. That's what the aggregation framework gives you across your data. And it's built to run against your data on the server, so it really is intended to be running right next to your data and get you a high-performance answer. People build a lot of real-time functionality on top of aggregation, based on what their applications need. Kind of going back to like the sort of the query side of it, support for range queries, querying within arrays, querying within embedded objects. We can query across every type we write. Range queries aren't just for numerical types, they're for dates, they're for strings. We also have support for regular expression searching. So a lot of what you might do with the SQL-like operator can be done here. There's lots of trade-offs. I'm not even scratching the surface on what's possible, but a lot of what you're trying to do is capable in there. It is intended to be a strongly consistent system. So I say intended because out of the box, it's strongly consistent, but you actually have a lot of capabilities to tune the system. So if you go back to the CAP theorem, it's like, somebody tell me what the C stands for again.
Consistency.
Thank you, drawing a brain fart. Consistency, availability, and I think it's partition failure tolerance, effectively.
Partition tolerance.
Yeah, thank you. MongoDB is probably I think it's a CP system out of the box, but ultimately you can sort of tune that depending on how you want to make it work for you. There's always performance trade-offs. If you look at something like Cassandra lets you tune that almost on like every operation. We give you a lot of the same capabilities. So by default, MongoDB is strongly consistent. But you actually can make it eventually consistent if you want to. Right? You can read from secondary locations. You can jack up availability in the face of failure, all that. So it is intended to be as sort of custom as you want it to. But out of the box, strongly consistent. Support for a lot of different indexing strategies. So just like I said, we have secondary indexes. So you can basically index anything that you model in your JSON documents. We also have support for things like sparse indices. Let's see what else. Geospatial indexes, obviously. Those geospatial indexes are pretty cool. If you guys have ever used Foursquare, a lot of Foursquare's geo functionality is actually built on top of MongoDB. We actually have two geospatial indexes in MongoDB. There's one that's kind of a flat 2D index that lets you model any sort of two-dimensional surface. You sort of supply the lower left and the upper right coordinate space, and then it just models it flat. Or you can use the spherical index. And it's still 2D, even though it's called spherical, but the idea there is it's actually mapping the surface of the Earth. So if anybody's really into like radians, you'll kind of know what that means. Effectively, it's like 1 degree of latitude is not the same as 1 degree of longitude unless you're at the equator. Everywhere else, it's a little bit different. And so the query mechanism, the index mechanism, takes that into account. So you can actually get accurate geospatial queries that map to effectively latitude and longitude within your database. And we actually have support in the 2D spherical index for GeoJSON, which is like an emerging geospatial standard for JSON, surprisingly. It actually lets you map 3 different types of objects right now. So it's like a point, a line, we call it line string, a point, a line string, and a polygon. And you can do things like intersection or nearby queries of those objects. So you could almost build like, think of like OpenStreetMap or something. You can actually build a lot of like routing and sort of point of interest functionality on top of MongoDB. And in fact, what we're going to be shipping in 2.6, which is our next major version, sort of, I think, January, February timeframe, we're going to be adding support for multi-locations within documents. So we'll add support for multi-point, multi-line, and multi-polygon within a single object. So you could have, for example, like one object that says it contains multi-polygons. Each polygon corresponds to like a county in the state of Texas, right? And you can start doing things like, well, show me all the points of interest that intersect these 2 county boundaries. So a lot of that functionality is actually possible. It's a pain to write if you've ever dealt with lat/long before, but it's pretty powerful. Support for most programming languages, I would say that's quite a bit. So MongoDB Inc., the company, actually has dedicated teams for each major driver. I call them like the tier 1 driver. So Python, Perl, Ruby, Node, C++, Java, Scala, .NET, PHP. There's even like an Erlang and a Haskell driver out there, but either the Erlang driver was written by the Haskell team or vice versa, but it's not. I think one of those is sort of not perfect in some meaningful way, but we've actually gotten a lot of support from the community on, if you look at where people have contributed code to MongoDB, a lot of it's been in the driver side of it, not as much on the server side. So you've seen a lot of community drivers that are built on top of our own. So a lot of support for things like, a little shim over our Java driver to make it less verbose. People have written async drivers, like there's an async Python driver, there's an async, I think, Java driver and a Scala driver. And then we've also seen just whole efforts come out of the community. So we've got a Go driver, right? That's actually written by someone not at MongoDB, which we actually internally use quite a bit. Like that guy consults with us regularly. So it's a totally well-built driver, and it's straight from the community. So that's where you'll see a lot of kind of community involvement on the driver side. The document model is intended to be very flexible. And so that means that each document has its own schema. So I might store, a list of users, right? That could be a collection of data I keep. Each of those users may have slightly different fields in them, and that's okay. The model is built to support that. The indexing structure, the query mechanism, all those things work with that kind of data, so they can be very iterative. You may not capture last names or middle names for all of your users. You may have them for some other ones. That's okay. If you build an index around it, we'll index the ones that have it. You can actually query against that field. If it doesn't exist, we won't look at that document. So we're trying to help out a lot of those ways. If you want to get started with MongoDB, frankly, the easiest way is just to go download it for your host system. Like I said, there's pre-built binaries for Windows, Mac, and Linux. Most built-in packaging systems, I think, are mostly up to date. And there's also some other ones, like we also have a Solaris build. Obviously, you can build it from source if you want to. And then there's some other, if you go to this page and go to the bottom, there's some other ones, like if you want to build FreeBSD, it's in the ports tree out there somewhere. Getting started with MongoDB is actually pretty frighteningly easy. Download the tarall, untar it, make a data directory, and then run MongoD. MongoD is like the core database daemon process that runs. And that's pretty much it. Once this is started, you can actually open up another terminal window and open the Mongo shell and start reading and writing data immediately. The Mongo shell is basically the sort of fastest way to interact with the system. It's just a full-blown command line interface for not only reading and writing, but like administering the system, setting up replication, setting up sharding, all that stuff. Yeah.
Is it implied that the root user is executing those commands?
I mean, I think they shortened it for this, but that wouldn't be the goal normally, no.
Okay.
So yeah, if you probably would need permissions to actually make that directory if you needed to. I think this is assuming like a dev laptop kind of situation.
Okay, but everything else though is just whatever you're in your user account. You're not expected to.
Yeah, you're not expected to. Most deployments, like if you go like a typical production Linux deployment, you probably have like a separate MongoDB user that you run it under with like an init script.
Okay.
If I'm talking too fast, please let me know. So this is what I was talking about, the Mongo shell. So once you fire up the Mongo shell, it's actually going to connect by default on the default port to localhost. And it's just going to connect and basically let you start working. So, you know, if I typed in something like db.test.insert, as soon as I connect, what it does is if you see this line connecting to test, if I don't specify a database, it actually just connects me directly to the test database, which is sort of a sandbox, if you will. As soon as it connects that, it binds the db variable. And this shell, by the way, is all JavaScript. So if you know JavaScript or you know a language like JavaScript, this is pretty easy to navigate. You're effectively writing JavaScript functions here. That's all you're pretty much doing. So here all I'm doing is I'm going to say db.test, so db is the test database. .test is the test collection. And then I'm going to insert a document to that collection. And the document's pretty simple. It's just a little object here. It says text, and I set this to a string value that says welcome to MongoDB. And that's it. As soon as I insert that, I can go ahead and query it back out just by doing a basic find with no parameters. So I'll just do db.test.find. .pretty actually is a nice little convenience in the shell. If you don't use .pretty and you have a lot of results, it just kind of streams them all out. But if you use .pretty, it does like a nice little JSON formatting with some indentation, so it's easy to read. One of the things you'll notice about this is there's two elements in this JSON object, right? Well, I wrote only one text, but I actually got back two. So if you don't specify an underscore ID in your object when you write it the first time, we'll add it for you. And that underscore ID is something we automatically generate. Object ID is made up of a bunch of bytes, but it's like date, time, a sequence number, and some other like kind of underlying information about the process. You can use our ID mechanism, or you can use your own. There's really nothing holding you to ours. We just have to put something there because there's a default index, a default unique index on the underscore ID field. Think of it like a primary key, and that exists no matter what. So if I had put, you know, up in here db.test.insert underscore ID equals foo, that'd be fine. As long as the value's unique, we don't care. And again, it can be anything. It can even be like a compound JSON object with multiple keys and values embedded. So it is a little wild westy in terms of what you can write to the system.
When you set it once, is there a way for it to be sequentially generated the next time, or does it have to be? Do you have to manage it so that it's a unique ID every time?
No, every time you call it ID, it'll regenerate one for you, or it'll generate a new one for you. It is not guaranteed to be completely unique in a really large cluster, but within kind of a single instance scenario, you're basically guaranteed to be unique because it has like a built-in sequence counter in the background, and it uses date time as well.
If you're generating your own IDs, then you need to take care of that in the application layer. So there's not a formulaic, substitution you can make. Right?
Yeah, it's either use the one that we make for you, or you bring your own.
Right.
And I would say it's like a mixed bag between what people do. Object ID tends to be pretty long, so a lot of people will use their own, or they'll use like their own, UUIDs or like a generated hash or something. But it's really up to you. Or depending on where the data came from, it might have already had IDs attached to it.
How do you know where is your database? Like you said it's not database /db, but it's been a while, so I don't even know where my database is. But I have Mongo installed. How do you know where is the database?
So if you look at the running Mongo process, you can so by default we'll always use /data/db.
Okay.
And that's always the first place to look, but you can also run, at the shell, you can run something called like, I think it's db.get command line ops or something. And it basically tells you what the system was started with, so you can actually kind of figure out where the DB path is. If it's not specified there, then it's using the default. So you can figure that out. So some of the terminology that we use, and I probably should have put this earlier in the slide deck, but if you think of kind of mapping like the terminology from relational to MongoDB, a table in relational is a collection in MongoDB. A database is still a database, so that nomenclature still stays the same. A row in a relational system is more akin to a document in MongoDB. Indexes are obviously the same. There are no joins in MongoDB, right? So that's what I said a little bit earlier. One way to work around or work through the kind of issue, because joins don't exist, is to use the structure of embedding data in there. So a lot of the reasons you might use joins are to represent some relationship, like one-to-many, one-to-one, many-to-many, whatever. A lot of that can be actually modeled within your data as part of your JSON. So if you think of like, I don't know, a really silly example would be like, you've got a person table and you've got a list of all the cars, right? And you have tied back to like, which person ID owns which car. If you were to represent that in MongoDB, you could actually just make each person object have an embedded array of all the cars they own, right? So that one person now stands alone. You've gone from 2 tables to 1 collection. So again, joins don't exist, but depending on how you model your data, and this is where a lot of the flexibility comes in, you don't need to have that, right? That problem sort of goes away, that lack of capability.
Can you do many-to-many?
You can do many-to-many, but we don't actually have like a built-in dereferencing mechanism. All that stuff that happens at that layer of relational tends to happen at the application level with MongoDB. So you can have a many-to-many relationship. You could actually model it completely yourself, but it's up to you to kind of enforce some of the round tripping and some of the any kind of constraint checking you want to do. It's up to the application at that point. A partition in relational is a shard in MongoDB. That's what we call it. So we call it kind of an individual partition of your data or some subset. So one of the things we'll do, one of the things that's in the slides is a kind of a brief walkthrough of modeling like a simple blog system. It's not all full of best practices. There are a couple of things you might not want to do in the real world, but it should give you a sense for how a system like that exists. So the first part of this is always kind of figuring out what your top level objects are, right? What are you trying to work with in MongoDB, right? So these are things like blog posts, comments, people, that sort of thing. If you look about it, right, you've got users, which are obviously authors of your blog post. There's the actual blog post data itself, so article, any kind of metadata associated with that, like date, time, views. And you've got things like comments, and you may want to like have your post tagged, right, for some kind of categorical mechanism later on. So if you were to do this, obviously with relational, you would start with, kind of like an ERD diagram, where you've got, a very normalized structure that you sort of build out up front. With MongoDB, it's a little bit different, right? You're actually going to go through and just start building the data. You're going to start just writing data in the format you want to work with it in, and start saving it that way and persisting it, and then start reading it back out as you need it. So this is just one approach of the way you could do it in MongoDB. You may have, an authors collection that's separate. You might not, right? There's no enforcement here. It really is up to you and how you need to define it. I often tell people the best way to kind of design your data model, or at least the first version of it, is think about the application you're trying to build. Don't build a really great blogging data model. Build, in your head, kind of build out the requirements for what a blog looks like. How is it going to run? What are you going to let people click on? Are they going to click on tags and browse by tag? Are they going to click on authors and browse by author? Are they going to sort posts by date, time? Are they going to sort by comments? Like, think about those kinds of requirements that affect your users, and that's the kind of stuff that you should use to feed your data model. That's how you should build it around it. Because really, you always want to prioritize, that first read or kind of reading and writing in MongoDB at a high level. You don't want to get into the guts of designing a great document model that actually doesn't fit your application later on. The whole purpose here is to make something that really fits your app and lets you scale your app really well. So if we were to start with something like this, where we were building like a blog system, we might start with like a single user here, right? We're just going to create an author that we'll use, and it's got a username, a first name, and a last name. That's just a single user object, right? This is something you could just cut and paste into the shell. Next thing we'll do is we'll switch to a new database. So if you remember, when you first fire up the shell, it binds that DB variable, that global DB variable, to the test database. If you want to switch that to another database, you would just say use database name. So in this case, we'll say use blog. It'll actually switch to the DB blog. Now, bear in mind, we actually haven't done any creation here. We haven't actually done anything outside the shell. So when I do this DB users.insert, what it's going to do is inside the database blog, inside the blog database, it's going to create a users collection and insert that first record. So by virtue of running this command, what's actually happening in the background is the MongoDB process is actually creating the files in the file system. So it's actually going and creating the actual memory mapped database files for the blog database, and it's actually creating this collection on the fly. And so this is sort of good and bad, right? The good thing is that you don't have to worry about kind of going through this step. It's sort of done automatically for you in the background. The downside is if you have a typo, if you mistype something, or you say users and another, one of your colleagues says user, right? You have a kind of a name mismatch, that's a problem. So you have to have some agreement ahead of time of your naming structure for your data. Otherwise, you could be inserting data into different collections, because we do create them on the fly for you. So effectively that's it. We inserted that first user, and there was an object ID associated with that user we inserted. So now if we go back and we're to do a find, so there's a convenience method in the shell that does a find one. It actually just finds the first record in that collection by default and does like a pretty print on it. If we had just done a basic find with no arguments, it would have brought back that same record. Since there's only one right now, it would have brought back that record. But within the find, you actually have the ability to, again, search for different parameters. So I could have said, find me the user with the first name Andrew. I could have said, if I had date times here when the user document was created, I could have said, find me all the users created between this time or that time. You actually also have the ability to pull back only individual fields. So here we're actually pulling back the whole document, but you can actually say, well, I only want the username back, or only want the IDs back, or the last names. So you have that flexibility. You can do what we call projections. So you can query for a bunch of documents, but only get the fields back you really want to. And for those of you guys that have done a lot of relational database work, that's actually pretty powerful. As you get into like really large scale data, if you've got an index on a field like last name, for example, you can actually do a query and say, well, I only want the last name field. Because the field last name is in the index, you can actually get a completely covered query that only hits the index and doesn't actually have to hit the source data itself. So that functionality is also in the system, it's baked in. So now if we want to create a blog post, we'll do another insert. So we'll just do this inline. And if you notice, we haven't created the article collection, but we're just going to do it here by virtue of inserting a document. So we'll use the DB variable. We'll create a new collection called article, and we'll insert a document there. So there's just a post title, some body text for the post, a date. This date is actually specified here as June 20th, 2013. If I had left date empty, it would have just evaluated it immediately and put the current date in there for the date object. I've got a username I've associated with this, so I can tie it back to the author. And then I just put some tags. And a tag is just an array here of strings. But it could be an array of anything, or it could be an array of embedded documents, right? Embedded JSON objects. And then I've got an empty comments field here too, so I can add some comments later. But again, that doesn't really have to be there because you can add that field in later if you need to. So now if we go ahead and pull this back and just do a simple find, we'll get the article we just saved in to the system as it would print out from the shell. Now if we want to do something like query by the array, so we're going to query across the tags field. So here all we're going to say is do a find. If you look at the components to find, and this is sort of true of MongoDB generally, everything is JSON, right? Your data that you read and write is JSON. In fact, the way you write your queries, the way you write aggregation framework queries or pipelines, the way you do updates, all of that is really just JSON. So you're always sending in a JSON object. In this case, for a find, you're basically saying, I'm going to send in a JSON object and find me everything that matches this. Because tags is an array, it's going to actually look at that field and say, well, show me all the articles where the tags field contains the entry adventure. So, excuse me, it's actually going to go through this and say, all right, well, tags is an array, adventure is one of the items in the array, and pull it back. Right? It's pretty smart to know what's an array and what's not, so you can query against it effectively. And you can actually create an index again against the array field if you want to. If we want to do something like update. Now, updates are actually pretty cool. That's actually one of the, in my opinion, it's one of the cooler parts of MongoDB. Updates are built to be done inline, right? They're in-place updates. So that means when you go update a document in MongoDB, you're not actually pulling the JSON out and rewriting it. You are actually just going inline or in place wherever it lives and just changing the information or adding something there. There are some other caveats to that, like if you grow a document beyond the space we allocate for it initially, then it has to relocate it. But generally speaking, if you're doing things like incrementing a number or adding a field or removing a field or just changing a value, it's going to do that in place. It's going to do that change in place. That actually has a really positive impact on performance downstream. Right? You think about it. If I were to do this in some other systems, it would read the document back out and then rewrite it. Right? That's a lot of data that's gone across the wire. Even if it's just bytes, that adds up really quickly. The way MongoDB works with this command, what it's doing is there's two parameters here to the update command. The first one is a find, right? It's just saying find me the candidate document that matches this _ID. And then it's going to do this command called push. This second command here, that's all that's sent across the wire, right? It's just sending that one section of push, and it's actually going to go apply that on the server in place. So what push does actually is it looks at a field and says, all right, well, I'm going to push onto the comments field this comment object, right? This object has two fields, name and comment, and it's going to push it onto comments. If comments didn't exist, right? If that empty array didn't exist, it'd actually create an empty array and make this the first element. Since it already exists, it won't create it. It'll just actually make this in, the first entry in that array that was there. So if we were to go pull that document back out, what you'll see is we go do a find again by the ID. We pull the document back out, and you'll notice there's now inside that comments array that was empty before, we've got a comment object. And you can actually index, just like I said, anything you write, you can index around. When you want to index stuff, you don't have to specify just top-level fields here, right? You could create an index around like date or title or username, but you can actually also create indexes around embedded objects. So something like comments.name. Let's say you want to create an index around all the names of commenters. You can actually create that by creating an index on the field comments.name, right? We use that sort of dotted namespace syntax. As there are multiple of these comment objects in that field, it'll actually create an index entry for each one of those. So, if another person, Bob, wrote another comment, and you create an index around that top level field, comments.name, it'll index every entry that corresponds to that. So it actually does do the smart thing about indexing everything that's in that array. So that dotted syntax is actually very powerful as well.
Is that query case sensitive?
It is case sensitive, yeah, everything's case sensitive. The only way to do a kind of a case insensitive search would be to use a regular expression search, but use of indexes of regular expression searches is kind of a mixed bag. It's more like, if you think about a regex, if you anchor it to the very beginning of the word, case sensitive, then everything after that then can still use the index. But if you don't anchor it to the beginning, then it's not going to use the index. Basically, it has to do a full table scan.
But you can't just say queue this name and make it case insensitive.
No, you have to. Yeah, you can't do it that way. It's assumed to be case sensitive.
You mentioned that the update is inline.
Mm-hmm.
So does it actually do an override or?
So in this example, actually, what it would have done is it would have gone, it would have gone to the actual document on disk or in memory and said, well, I need to add more data to it because it's beyond the bounds of what I've specified in my initial document. I actually have to take it out of there and relocate it. So this is actually an example of a not a great practice. This is a little bit of an anti-pattern of MongoDB. You want to try to structure your updates in your update approach such that you're not growing documents, because growing documents have a penalty of having to be relocated, and it has I/O overhead, and it holds the locking and reduces concurrency a little bit. So you're better off saying, again, this is not a great example, but it's a good starting point to think about. But you're better off saying, well, if I'm updating a lot, I want to make sure the fields I'm updating already exist, or I've created space for them in advance. Because when you save a JSON object the very first time, we allocate just that much space for that document by default. We don't give you any extra padding by default. There are other ways and other tweaks in the system you can do to turn on some extra padding, but you want to manually control that yourself. You don't want us to do it. Once we start relocating documents, then we start padding things with extra space, and it becomes inefficient, and you effectively end up with fragmentation.
Should your original document have that comments place?
It did have the array, but it didn't have any
Didn't
entries.
have any entry.
Yeah, if I put in like just an empty entry or like a bunch of nulls in there, it would have saved it in the space it already had.
So my question is like, for that blog post, you have multiple comments, right? So what is the versioning as part of version?
So there's no versioning built into the system, right? Any versioning, any kind of version management around the document structure is managed by the application level. So it's something you can do, and a lot of people do implement a versioning strategy, but it's not something we give you out the gate. Any other questions so far? So that was a really, really brief example, not full of like what I would call all the best practices in the world. So if you have some thoughts on a schema like this that you're thinking about doing, please find me after the thing and come talk to me. We can just go to the whiteboard and sort of talk about options and how it would work. And I'll talk a little bit about another use case in a minute after we finish. So obviously, you're not building applications in a shell. You're building them with your programming language of choice. So like I said, we have dedicated teams for each of these drivers at MongoDB. So there's like a team of 2 or 3 people. In fact, I think back in November, one of the guys from the Python team, Jesse Davis, came down to give a talk in the user group. Jesse's really cool. He's been on the Python team for a long time. He's actually the author of Motor, which is an async driver for Tornado. So if any of you guys use Tornado with Python, he wrote a driver for that. That's asynchronous. As it turns out, MongoDB is really popular, obviously, with a variety of languages. But we were looking at metrics about this internally lately, or recently at least, and .NET and Java are actually two of the most popular drivers. And in fact, they're actually going through making sure architectural changes too. So there's a lot of good stuff coming out of those drivers soon. Like Java's going to add built-in asynchronous support from the driver from us in its next major version, which is supposed to ship in the first half of this year. .NET's adding some of the same thing. Each driver implements the same basic API, and we try to use the same nomenclature across the board for things like the connection types and stuff. But we still will try to make all of the kind of object work that you do with your data as native feeling to the language you're working with. But some drivers have a few little extras, like the .NET driver actually has a built-in serialization and deserialization mechanism to BSON, so you can actually do a little bit more work and build more intelligent objects in the .NET driver. But again, third-party stuff exists on top of Java driver as well. Like there's support for Hibernate and Spring and other random libraries. So there's a lot of stuff out there. Python has the same thing. There's a project there called Mongo Engine. It gives you some object type semantics and some control over data model and schema at that level.
Do you have support for Go?
We actually, that's a great question. I'm glad you asked that. So the Go driver that's out there is not from MongoDB. It's actually from someone in the community, but we work with this guy really closely. He's actually in our office all the time. A lot of our internal tools and other tools we're shipping are actually based on his driver. It's pretty well built out, and I would say it's very much a production level driver. So that's come from the community. We've actually tried to hire him, but he doesn't want to work for us right now. I think he prefers to freelance it. And then, like I said, there's the community's given us a lot of other ones. So there's other projects that do a Node driver. There's other .NET drivers out there, and this is true of the way we do things. Like we had a .NET driver for several years, and then somebody in the community wrote a better one. We just hired him and just ripped out ours and used his. So we're willing to make changes and do the right thing for the community as far as the drivers go, because this is the way you talk to the database. We want to make sure it works as best as possible. Same thing is true of the Node driver. And there's other ones out there, like there's other Scala drivers, not from us. There's a Lua driver. There is an R driver out there, but there's two versions. There's one that uses R Java, and there's one with the C++ extensions built. I think it's kind of a mixed bag depending on which one you want to go with, but they do exist. So it's at least a starting point. Docs.mongodb.org, if not already, will become your best friend. I've worked on a lot of open source projects over the years, a lot of stuff in Hadoop, and I will tell you that MongoDB's documentation is fantastic. It covers a lot of stuff. It's not just about the database, it's also about how to use the database. There's a lot of walkthroughs on how to set up high availability and replication, and how to shard, and how to take a replicated deployment to a sharded deployment, or how to build different types of applications. We've got lots of docs on individual use cases. So if you say, well, I want to build a product catalog that sits on top of MongoDB, we actually have code samples and even things like, well, if you want to shard this catalog over time, here's a good shard key candidate. So we'll walk you through a lot of stuff. The site is really, really well built out. We are, very serious about having some of the best docs out there. But we cover a lot of stuff. So not just the database stuff, we also cover a lot of ecosystem things. So a lot of driver things, a lot of community driver things, talking about things like AWS or deploying on other cloud platforms, around deploying on Azure. So the sky's the limit as far as the docs go. And it is very regularly updated. It's constantly being worked on, so we can always add content.
Is the documentation itself open source? Do you accept pull requests?
Yeah, we do. Actually, the docs are hosted on GitHub, and we take pull requests all the time. And if it's not something that you can write, just obviously write a pull, or write an issue, and we'll turn it into a Jira ticket, and it gets assigned to an engineer. So that happens pretty regularly. So we get a lot of comments on our AWS docs because people want more examples of stuff. So they're all sitting in my queue, unfortunately, right now, but I'll get to them soon. There's also online training. So we actually have a free online training at education.mongodb.com. And these are 6-week classes. There's two flavors. There's kind of the dev flavor or the DBA ops flavor. The DBA Ops class is actually taught by Dwight, who is our chairman. He's one of the original authors of MongoDB, one of the founders of the company. So he teaches that class. The driver team developers tend to teach the dev class. So you'll have like, MongoDB 101 Python, MongoDB 101 JavaScript or Java. So those are taught by people who are really close to it, right? This is not third-party stuff. This is all done through us. These classes are running all the time. So if you're interested in just kind of playing along, it's, I think, 6 weeks for a class. I think it's like 2-3 hours of homework kind of every week. At the end, you get like a certificate. And then there's like a special little like MongoDB question and answer group for people that have completed the class. So if you want to talk to us more, that's out there. We also have a very active Google group mailing list. Everybody at the company is monitoring the Google group and keeping track of it so they can answer questions, including all the engineers. Same thing for Stack Overflow. We keep a really close eye on anything tagged with MongoDB. So if you have a question and you don't know an answer, go there, right? We will get back to you in some way, or the community will, right? Someone will help you. So we've gone over a lot of stuff here. There's a lot of stuff we didn't really touch on and we didn't get a chance to get to, but for any questions on some of these topics, please come talk to me after, or talk to Brandon, or there's a bunch of MongoDB guys up here in the front, or Kenny somewhere, David's back there. Find us, we'll definitely talk you through it. But there's a lot of content on the docs about things like schema design for different use cases. We didn't even touch on replication, but we have a built-in mechanism to do replication, so you can get high availability, you can get disaster recovery built into your deployment. Didn't even get to the internals of indexing, but there's content out there on that. There's talks on sharding, and there's content about that. One of the things that we're really good about, or depending on annoying, depending on how you look at it, is we archive every single talk, every single webinar we give. So we do these things on a weekly basis. We're always giving a talk on something. Like a month ago, I gave a talk on how to model time series data in MongoDB. We archive those webinars. They're all there off of MongoDB.com. They're like 45 minutes to an hour, or there's talks on replication, basic replication, advanced replication, basic sharding, advanced sharding, schema design for different use cases. Just go sit during lunch one day, and if you want to learn about a topic, just watch the webinar or go through the slides. There's a wealth of content, and we're constantly adding stuff. We're constantly delivering new things to put up there. The last thing, and I'm not saying no more questions, but I did want to put this up. So we are having MongoDB World in New York, June 23rd to the 25th. We're going to get a lot of people coming out. So if you guys have been to a MongoDB conference before, they're typically 1 to 2 days, and it goes over stuff like I just talked about, building your first app. It talks about replication or schema design. MongoDB World is kind of the next generation of that. We're trying to get talks that are a lot deeper, a lot more in depth, but we're also going to have a lot more breadth around different verticals. There's healthcare and financial markets. There's a lot of data, a lot of presentations coming. Basically, it's going to be the one big MongoDB event for the year. We're still going to do individual city events, but they're going to be a little bit smaller in scope. So if you really want to, learn from the experts, but also be able to talk to them, by all means, come to MongoDB World. We actually have dedicated time over the course of 3 days where people are sort of slated to have Genius Bar type sessions where there's basically 10 people in a room, come and ask them your questions. They're all engineers or architects that work at MongoDB. And if you want to sign up, or if you want to register for the event, we're doing a 20% off the registration right now. If you just use the code Austin_mug, you'll get 20% off the ticket. With that, are there any questions? No? Okay, I'm just kidding. Yeah, any questions? I think I can answer.
So you showed that user structure.
Mm-hmm.
So if the structure is already existing, and if I create a structure with different elements in it, will it go and merge those, or it will create another user object?
So it depends. One, if you have the _ID specified, it's the same as an existing ID. It'll actually complain and say a duplicate key error because you broke the uniqueness. We couldn't enforce uniqueness on that constraint, so it won't let you insert that. If it doesn't have any unique index information there, then it'll just insert a new document. So you could have 2 documents with the exact same data but with different IDs because they didn't violate the uniqueness constraint on the _ID field. But there actually is a separate method called upsert in the shell and in the drivers that will let you say like, look for if it's there and update the fields, and if it's not there, just insert it.
No, that's for your DML action. I'm saying like when you said the first statement was use.
Oh, use, yeah. So
when I do that,
yeah.
let's say if my JSON is totally different than what is residing in the database, will it go and merge it, or will it complain that this is not matching?
No, it'll complain. Yeah. I think if I understand you correctly. So, I know I mentioned, downloading MongoDB and getting started is really easy. Obviously, you go to the download site, download it, untar it, run it. There's actually also a number of other ways you can deploy MongoDB, or you just run it in a more kind of real world scenario. So for people that are really big on Amazon, we try to work really closely with AWS. We have a lot of content. If you just Google like MongoDB EC2, you'll find like a page that documents like how to deploy an instance and set it up with all like the settings we want you to have, install the packaging. We tend to use Amazon Linux because it's the most up-to-date kernel for the platform. We also have instances that you can run out of the AWS Marketplace. So this is like, do the one click on the Marketplace and it just launches an EC2 instance that's pre-configured with MongoDB up and running. The only thing is, I think MongoDB is not set to start on boot on that instance. You have to just start it up by hand, but otherwise it's kind of pre-configured. It's got pre-configured storage because there's a lot of caveats and nuance to managing storage on AWS. We also have docs out there for running it like in Rackspace Cloud or for deploying on Azure. A lot of platforms as a service like OpenShift and actually Azure Platform as a Service also support MongoDB. There's also companies like MongoLab, MongoHQ, ObjectRocket. They let you actually just deploy MongoDB in the cloud like immediately. You don't have to do any legwork. You just basically sign up and launch with them, and they give you the credentials so you can work against it. So there's a number of ways to get started. That's actually not the hard part. The hard part is kind of figuring out what to do with it after that. But I would say, look at the examples that are out there. Think of an example you're trying to model with your own work and just try to iterate on it a little bit, see if it fits in MongoDB, see if you can model what you're trying to do. And model the shell for that matter. You don't have to like get a full-blown environment set up. Just start working with it and start playing with it so you can get comfortable. Yeah, with that I think I'm done. Yeah.
In which types of scenarios is preferable to still use the relational database management?
Yeah, a lot. A lot. I mean, I think there are probably more than I can think of off the top of my head, but yeah, this is not a drop-in replacement relational system. It's a replacement for a different approach to the problem. If you look at sort of the space of like possible relational use cases out there, MongoDB can actually satisfy a lot of them, but not all of them. Right? There's still a very healthy percentage of relational use cases out there. Anything where you do have to have cross-table transactions or the ability to do rollback and commit, like some of that stuff just it will always exist and work in those systems better. Definitely not, it's not dropping like that. Yeah.
So I think you touched on a little bit, but what is the primary difference in MongoDB, CouchDB, and Cassandra?
So it comes down to, also, let me forget CouchDB for a second, because CouchDB is kind of in a weird spot right now. So I would focus on Couchbase there. But if you look at Cassandra and Couchbase, those are probably the two we talk or hear about the most. I'll talk about Couchbase first. So Couchbase is actually, if you look at its roots, it's actually Membase, which was Memcached, just persistent. So Membase became Couchbase. So what Couchbase is effectively a key value store where the values can be JSON, and you actually can build what's called materialized views on that data with MapReduce. So it does expose a lot of the JSON elements, but you have to sort of write the secondary indexing mechanism yourself. I tend to still see Couchbase as a really high performance key value store with a lot of great distribution built in. Cassandra is a little bit different. Like the data model is not JSON centric. It's more of it's a column oriented store, but not really. It's like a wide column store where you can have like a row that's got a bunch of columns in it, and you can have like up to 2 billion columns, and every row can have a different set of columns. So it's kind of similar, but their secondary indexing is dramatically different. You can't really index secondary fields in Cassandra that have high cardinality. They tell you to use only low cardinality, and that's just kind of the data model. The deployment side is drastically different too. We tend to take the approach of like dedicated replica and failover nodes. So if you look at a MongoDB deployment, like a good high availability deployment in its basic form is 3 nodes, right? A primary and 2 secondaries. In Cassandra, that might only be 3 nodes as well, but just that it's those 3, they share the workload across the board. For us, in that 3-node setup, one's your dedicated read and write, and the other 2 are just there for failover. So we have dedicated replicas that have kind of a shared replica approach.
So with Cassandra, you can never really get a guaranteed consistent read. It's
Yeah, like Cassandra.
consistency.
Cassandra.
The concept of the single point of access to the cluster.
Yeah, like reads by default in Cassandra tend to be eventually consistent. Writes, like Cassandra is a great platform for writing lots of data. It's great if you write a lot and read kind of rarely, or you can read across the board, because you don't really have a single source of truth in Cassandra the same way. So it's just a different consistency model, but that's totally tunable, for performance trade-offs.
Yeah, also Cassandra strongly encourages you to write to store data in a way that so your query patterns will basically encompass the scope of a single node, which leads to aggregation limitations across partitions. So there's again, as Sandeep pointed out, there's some very valid use cases for Cassandra and key value store. What we look at with Mongo is that we feel that it provides a very good trade-off of functionality and scalability. And so if you really look at it on the cat triangle, if you look at Cassandra, it's more of an AP solution. They're worried about availability and partition tolerance, not consistency. But we feel that consistency is actually a very important aspect of most database data-driven applications. So having a consistent read by default is more important than having availability guarantees, because we can address availability guarantee at the driver level, right? If maybe when we see a secondary, primary step down and secondary, a vote for a new primary occurred, if that cluster's offline for a second or two, the driver can always retry. So consistency is more important than having that availability guarantee.
Right. And we give you the ability to make that trade-off. So if you want to change that to be
Yes, exactly.
AP, you can do that, or be, CA, I guess, technically want to do that.
Yeah, or AP.
Yeah.
I have a follow-up question.
Yeah.
You said there's a primary and there's two secondaries. Secondaries only failover. But in relational, you have the same issue, right? You have a single server, and when you have high workload, the single server could be the problem here.
Yeah.
So how does MongoDB address that?
So if you take that replica set, that 3-node setup, that can become basically one shard, and you just sort of double that size. So you would say, go from one replica set to 2, and partition the data so that half lives on one replica set, half lives on the other one, and you've sort of doubled your write throughput at that point, or you've doubled your capacity at that point, if you will.
You see, that's the limitation of the relational system, is you cannot partition the data.
Yeah.
Right. It becomes in essence 2 separate data stores.
Yeah. So this is actually one unified data store, and we actually have a tool built into the system called MongoS, which actually you set MongoS next to your app server, and it actually intelligently routes. It sort of acts as like a transparent layer or an abstract layer over the rest of the cluster. So your application really has no idea how many shards or partitions there are. Your queries just talk to MongoS, and MongoS sends them to the right place.
I've got 2 questions.
Yeah.
One is the shell the only way that you can interact with the backend system, or is there other UI? That's my first question.
Sure. Well, I'll do that first because I'll forget. So the shell is the only way we ship. There are actually third-party tools, and there's an Eclipse plugin, there's a couple of Java UIs and some other tools. There's some other Windows-based tools for doing it, but we don't maintain them, so they're all community-driven.
The second question is, what is the security when you have to connect to? Is it all managed by the application, or is there any inbuilt security that MongoDB has?
So we have support for a basic authentication mechanism. I wouldn't say it's the most secure thing in the world. In fact, I'd say it's somewhat sort of insecure. But we have support for kind of basic username and password authentication. We also have support for SSL, so you can have your traffic encrypted back and forth. We have the enterprise authentication is where that really comes in from MongoDB Enterprise, so we can support a third-party authentication mechanism like Kerberos or Active Directory. But there is a basic kind of, like I said, username and password in there. And in fact, in 2.4 in MongoDB, we moved from just read only and read write access to having kind of a full-blown roles and authorization setup, where you can have different roles and different levels of permissions. In 2.6, it's actually turning into custom roles, so you can have a user that has the ability to maybe write data but not create an index or something.
But that's on the authentication side, but about storage itself, storing sensitive data.
So there's we don't support, built into the tool, we don't support any encryption at rest. So that's basically handled by tools like eCryptFS, or if you guys have heard of Gazang, they're local. They offer like a commercial eCryptFS solution. Yeah.
What's a reasonable limit to the size of the document?
So that's a great question, actually. So the document size limitation is actually 16 megabytes. So at 16 megabytes, if you look at that, it actually turns into, I think 16 megs holds like the text of the King James Bible. So it's pretty large. In reality, I would say objects typically don't go beyond, like, and just in terms of what I've seen with like customers and things like that, they don't go beyond like a meg or 2 megs, just in practice, because it just ends up being heavy to go back and forth across the wire. Even if you project only certain fields at a time, it still can be pretty large.
We do store, large blobs though using GridFS.
Yeah, actually, I forgot about that. So we actually do have a large object storage mechanism built into MongoDB called GridFS. It's a separate API within each driver, but what it lets you do is basically take binary data, and what we do is you give it let's say you give it like a 20 meg video file or something. We actually break that up into chunks of 256K and then store them in that way. So you actually have that ability to store large objects if you want to, and then just reference them later on. So you can pull
Nice
those.
thing about GridFS is it supports streaming. So let's say you had a large MPEG file and you wanted to advance to a particular timestamp. In the Mongo system, which is very unique, you can actually leverage the properties of GridFS to assist in advancing to that timestamp without having to read all the data.
Yeah, you don't have to read the entire thing. You can read portions if you want to. Any other questions? So let me mention one more thing before we go. I'm going to hang out, and if you guys have questions, but also we are hiring. So MongoDB has offices. Our headquarters in New York. We have a big office in Palo Alto. We actually just opened an office here in December. There's only a handful of us here now, but we're expecting to grow that quite a bit. We are hiring for sales, support, solutions architects. We're building a performance team that's based in California, but half it's going to be here as well. So, we've got a lot of stuff, we've got a lot of openings. If anybody's curious about working at MongoDB, please come find us. We're happy to talk about it. And I know Object Rocket is hiring as well, so by all means.
I was actually going to talk about that some. But we're hiring for all sorts of roles. I'm the lead DBA at Object Rocket. I'm looking for DBAs. We're also looking for DevOps pretty heavily. I think there's a couple more developer roles. We're very Python-centric. So if this stuff seems interesting to you, or if you want to solve really complex problems, we are known as the high-performance Mongo as a service tier. And one of the famous quotes is there was another partner, I won't name them, that said you couldn't go above 100 gigs with Mongo. We run several clusters in the 8 terabyte range. And so if that's the kind of stuff where you want to really get into the hard problems in Mongo, which it does have them, then come talk to me. But also if it's just exciting for you to work with NoSQL, I'm also looking for junior DBAs and really talented SAs and DevOps type people.
Cool. Thanks. Well, thanks everybody for coming out. If you have suggestions, please share them. We're going to do, obviously, a talk every month. If there's a topic you want to get into, regardless of what it is, just ask us and we'll find a way to fit it in. So, thank you, everybody.
Fourth Monday of every month.
Yeah.
So here at Capital Factory.
Cool. Thanks.